So good morning, one and all, and I think we were discussing about energy resources in the last lecture, and we covered basically when I talk about energy resources. I think so the main thing that is what we are discussing about commercial sources, energy resources, the conventional and non-conventional. So in the commercial category, conventional we have discussed in the last lecture, the coal, petroleum, the natural gas, then nuclear. Somewhat we have discussed with the rectors, if you remember. Okay, so I gave you no basic glimpse and the data and basically the facts and figures about all these conventional resources. Once you talk about non-conventional resources, and that is basically I want to say the energy resources for the future. If you want to live long with a healthy environment, the only option is we should shift for a non-conventional energy resources. And that's why if you see the whole world, basically whole world is looking for alternate sources of energies. And that's why I told you in the last classes also, okay, now they want the engineers or technocrats or technologists should work in the area, not in the core field, but in the alternative fields, so that the alternate sources, some other sources can be identified, technology can be modified, materials can be modified, machines can be modified, so that minimum energy consumption should be there. Number two, minimum impact on the environment should be there. And no, there are various aspects which are being associated with the non-conventional sources. Okay. Now, if you have seen that we have, like in India, we have really identified that we can go for world power in solar. We can go for number one in solar. So we are installing. No doubt, we have having some technical hitches also, and we have some other problems also when you talk about the solar energy implementations. Geothermal is also there, concept wind and tidal waves also there. So you have, these are basically sources which talk about, okay, we're talking about non-conventional energy sources. A lot of research is being going on in this area, and specifically I was telling you, during my lectures, now in the whole world they're looking after engineers, electronics engineers, mechanical engineers, all engineers, to have the better efficient panels. Like electronics engineers, they want better efficient panels, because solar energy, if we talk about solar energy, I want to start with solar energy, no doubt, after this slide. Solar energy, no doubt, it is a clean fuel, a clean way of getting energy. But the major drawback of solar is, when I want to discuss, is they need a very large area, because we need to capture the sun. We need to track the sunlight radiations, irradiations, basically. Okay, I want to say. So we need larger area. Number two, a lot of research is going on. Electronics engineers are really, a mechanical engineer, they are working in this kind of area, by designing a suitable particular, panels, so that less area is being required. Number two. And number three, I told you in the last classes somewhere, I think so, I remember that, like Japanese, Chinese, they are modifying the technologies so nicely, and they are making a solar panels like a roller sheet. Beautiful. I have seen that video. You must have seen that video. Means otherwise, like if you're seeing that kind of panels right now, what we are here in India, so we are erecting a lot of solar panels, and huge space is being required. To get rid of that, to avoid that particular, this thing, these countries like Japanese, Chinese, Korea, these countries are far ahead than us in terms of technology implementation. मेरे ख्याल से आपको बहुत एक ऐसे व्हाट्सएप पे या फेसबुक पे वीडियो आते होंगे, को जो प्रोडक्ट जो होते हैं, जो चाइनीज प्रोडक्ट देखे होंगे आपने, मगर आप उनके पास हर चीज का सोल्यूशन है, इतने कम्पैक्ट प्रोडक्ट है उनके पास, ठीक है. एंड इफ यू सी दे आर मेकिंग अ बकेट, एंड यू मस्ट हैव सीन दैट वीडियो ऑन फेसबुक, आती इतनी रोज प्रोडक्ट की वहां पे ऐड रहती हैं. वो बकेट ऐसी होती है कि व्हेन यू यूज अ बकेट, कंप्रेस इट, व्हेन यू कंप्रेस इट, अरे वो मतलब 2 by 2 3 by 3 सेंटीमीटर या 5 by 5 या 10 by 10 सेंटीमीटर में पैक हो जाती है, बस खत्म. Furnitures, then all the things. And TV they have made like foldable TVs. so so they are running like 50 years ahead what we are right now. So they're thinking 50 years ahead. तो वो टेक्नोलॉजी वो डेवलप करते हैं. Similarly, when you see video somewhere on the Facebook or on WhatsApp or Google or YouTube, you find that they have made a panels like a roll sheet. So once you have a sunlight, spread the sheets, harness the solar radiations, get it converted to suitable form, which I will be discussing no doubt, and evening roll it out, pack it and store it. It's beautiful, really beautiful. So this thing is required from engineers like you when you are basically studying, these kind of things in your engineering, how to apply these fundamentals. So with this brief discussion, I think so let's start the solar energy in detail. So once we talk solar radiation data, solar radiation particular brief about, so we know solar energy is the most readily available free and free source of energy. इसकी discussion करेंगे बेटा हम, no doubt complete discussion करेंगे इसके बारे में. हम आपके घरों का केस भी लेंगे, आपकी कम्युनिटी का केस भी लेंगे, हम थापर का केस भी लेंगे. सबसे बड़ी बात है कि यहाँ पे हम पढ़ाते हैं सिर्फ बेटा, यहाँ पे इम्प्लीमेंट नहीं करते हम चीजों, है ना. कैसे मैं बताऊंगा आपको, अभी हम थापर आके गए हो मेरे ख्याल सब, है ना. तो मैं सोलर एनर्जी के बारे में बता रहा हूँ, आपको पढ़ लो, डाटा आपके सामने है. आई वांट टू एक्सप्लेन ऑल दिस थिंग्स टू यू. अब थापर आके गए हो आप, तो मेरे ख्याल से डिस्कशन में बाद में हम क्लास के पहले डिस्कशन करेंगे. वी हैव डिस्कशन बिफोर द क्लास एंड्स. यू कैन जस्ट लेट मी नो, हैव यू सीन एनी काइंड ऑफ पैनल्स इन थापर यूनिवर्सिटी? In spite of the fact that we have a huge open area, your rooftops, your hostel rooftops, academic area rooftop, number 2, street lights, a huge sunshine is there. And in spite of the fact that we are harnessing or we are getting electricity from coal-based plants where the huge pollution is there, huge energy consumption is there. In spite of fact, this thing, we are getting a sunlight. So you're getting that particular electricity from the coal-based plant, which is not environment friendly, which is not energy efficient. Second, in spite of the fact that we have a huge open area in the campus like Thapar Institute. And third, in spite of the fact we are paying huge electricity bills per month. When the campus was running a full capacity, the per month electricity bill was near about 1 crore, 70 lakhs, 80 lakhs per month I'm talking about. see what I'm talking about. And still we are not going for any kind of these kind of energy resources which are really freely available. I agree with the wind, although we can have a wind also, because when a high-rise building, some small windmills can be installed depending upon applications, depending upon the design efficacy. But we cannot deny about solar. Okay. And if you see the data, solar energy is the most readily available and free source of energy. The sun radiates this much. See this, 3.8 × 10⁻26 watt of power in all the directions. And actually what is being received by the earth is this one. And India being a tropical country, the average solar radiation values for India is between this one. See, it's huge, 12.5 to 22.7 megajoules per meter square per day. This is a huge value as far as the country location, all conditions are being concerned. And you know very well, the solar energy can be used directly for heating, lighting, for home buildings, generating electricity, cooking food, water heating. So many applications are there, beta. Okay. Like I was giving an example to the students, like earlier on when they are in campus, to all the hosteliers. Okay. Like you have all the bathroom geysers in your hostels. For winters, you use continue this water geysers. So we can use solar water heater very effectively, in spite of using instead of using the electricity, using electricity for heating water, we can use some hostels they have, but like it could have been like that. It should be implemented throughout the host, this particular thing. So this is the hardcore fact that why I'm saying this, I'm not against Thapar, but why I'm saying this, it's a hardcore fact as far as India is concerned. Okay, we learn about the things, we read about the things, we cram the things, but we don't apply the things. And if you really think that I am wrong, then after this particular discussion before the class ends, you can really ask me how many students they have a solar panels in their houses. Okay, 1, 2, 3, 4. Later on, they can tell me, no doubt. Okay, later on, they can tell me. But if out of 16, if out of 80, only 8 students can say that, see the percentage of it. And still, with the fact that okay, you are having a very good amount of sunshine. See this. Now in summers, we have full-fledged 8 months of summer in India. 8 months of summer in India. See how much electricity can be harnessed. I know in some of the cities like Chandigarh, Panchkula, the government has made it mandatory to have. This is something we like can be done. Mandatory to have solar panels on the rooftops. Made it mandatory, and they given deadlines for that. And this is something being appreciated. Can be appreciated for that. Why not for other countries? Why not for other states? It's not like that your particular state is not receiving radiations. It's not like that you are not in that particular tropical area where sunlight is not there. Okay, so actually the amount of radiations received from sun at a particular place depends on certain factors. These are the certain factors which you can go through. Okay, no doubt these factors are obviously there. First is solar constant. This is particular constant value that refers to the extraterrestrial. What is the extraterrestrial? See the first line. See the first line, but you can get to know what is extraterrestrial solar radiations. This is basically the solar radiations which are being received outside the Earth atmosphere is called extraterrestrial solar radiations. Okay. So solar constant, first factor is solar constant. Solar constant is basically extraterrestrial solar radiations from for the mean distance between sun and Earth. It's a constant. So each and every country this have the solar constant different values. So they have a different kind of mean distance between solar and Earth because of the locations. Okay. So these values will be always taken from the internet, and these values are constant. And no doubt this is very, very important. The angle at which the sun moon rays strike the earth, you know very well. Now you are sitting at home, it's near about 10 o'clock, like 9:30. Okay, the amount of radiations which are being striking at particular place will be different. What exactly will be striking at 11 or 12 or 1 o'clock? So angle at which sun moon will strike the earth. So you know very well when sun is at the particular, at your head top, and the angle is very good, so striking the maximum radiation are being received. Okay, and no doubt number of hours of daylight in sunlight means number of hours of daylight in a particular day, means you start from what reading 9 a.m. you can't start because you start where the maximum amount of radiation is actually received, that is between 10 or 11 to 2 p.m. 11 to 2 p.m. So maximum, you can say if you take an average, it is 5 hours. You will get the maximum. Okay. So these are the some particular constants or values which actually you refer for doing the calculations. What are the actual radiation being seen? That is length of the atmosphere, also length of atmosphere, like sun, this length of atmosphere. After this, the sun rays must pass through before reaching the earth. After they cross the earth atmosphere, now it all depends on the atmosphere, length of atmosphere. Now length of atmosphere also, and the type of atmosphere also. No, in the type of atmosphere is like very smooth, so there will be a minimum like scattering of the radiations. If atmosphere is full of dust particles, some other things, some other gases particles, some other things, so it might possible that after crossing the earth atmosphere, before it reaches the earth, it may scatter, it may be absorbed, and the least can be actually reaching on the earth surface. Okay, so you can go through better fast. So this is something which we will be discussing in detail, no doubt. Just go through it once better. I'm going to explain this thing, no doubt. So solar energy can be utilized to two different routes, always two different routes. One is solar thermal route, second is solar photovoltaic routes. You know very well, I think so, but I'm going to give you a glimpse of all these things in this solar energy discussion. That is how the solar energy can be utilized. Okay, that is solar thermal routes and solar photovoltaic routes. So I'm going to discuss these things in coming lectures in detail. What is these exactly routes? Okay, so solar thermal energy can be can be converted to thermal energy, and that is true with the help of solar collectors. And how they are going to work, I'm going to explain in detail. Okay, in coming slides. Okay, so I want to show you the working of the solar collector soon, but these are the very good like converters when you want to say that actually how it is being converted. Okay, so solar thermal devices can be classified into three categories basically generally. So when we work on these kind of collectors, no, there are three type of collectors: low, medium, and high grade devices. Okay, low, medium, and high. These are solar thermal devices. And solar photovoltaic, no doubt I'm going to discuss later on. Solar photovoltaic means you are just talking about taking a photovoltaic cells, solar panels in that case. Okay, so in solar panels you have the solar photovoltaic cells are there. Basically they are semiconductors, and no doubt I'm going to discuss detail when I'm going to take this topic in detail coming lectures. And right now I'm discussing solar thermal devices. Solar thermal devices means solar radiations converted to thermal energy. Okay, and no doubt for converting that you need certain devices that are solar thermal devices. So these thermal devices basically are in three basically categories: low, medium, and high. Low grade means that you design the system so that the temperature can reach up to 100 degrees centigrade. Medium grade heating devices are being designed accordingly so that the temperature can be attained up to 300 degrees centigrade. And high grade means this is basically designed. I want to show you, no doubt, in coming slides. No doubt, that is how it is. High grade means you can achieve temperature above 300 degrees centigrade. Just imagine right now after seeing this slide, before I go to the next slide. See, without a single mole generation of CO2, without any kind of thing, other thing being converted, we can have a temperature, we can achieve a temperature increase of water to 200 to 50 degrees centigrade. And just can you imagine if you can increase the temperature of 200 to 50 centigrade, okay, you can really generate high power steam for that. And the steam really can, okay, steam can be used to run a turbine. And no doubt, you know very well from a mechanical engineering point of view, The turbine which is going to produce electricity is all depends upon the how fast the turbine is running, what the RPM of the turbine, and with what pressure, what pressure the steam is striking the turbine blades. So if you're having a high velocity, high pressure steam, and the two depends upon the temperature of the steam, also pressure of steam, also basically for the process onwards. So that particular steam is able to run a turbine at a higher speed, and like high electricity can be produced, high amount of electricity can be produced. That too without single mole generation of CO2. And this is a particular domain where the whole world is looking. Without using nuclear energy, without using nuclear reactors, without using conventional particular fuels, and without disturbing atmosphere, how can we go for a larger production of these kind of resources, energy resources? So there's a lot of work is going on in this area. Okay. So one wants to talk about solar thermal. The solar thermal collectors gather energy from the solar radiations delivered to thermal transfer fluid. I'm going to show you, no doubt. So basically, what is exactly there in solar thermal collectors? Just read it once. I'm going to show you. I want to explain you, no doubt. कुछ नहीं है बेटा. You are getting a sunlight, and sunlight, the energy from the sunlight is being transferred to some thermal transferred fluid. It can be gas, it can be liquid. So you're going to choose that fluid accordingly so that it can immediately raise its temperature. So once you are selecting a thermal fluid, transferred fluid, thermal fluid, तो fluid ऐसा होना चाहिए इसकी specific heat बहुत ज़्यादा है. Specific heat means it can really absorb the heat and release the heat. ठीक है नहीं? So we can use the thermal fluid accordingly. Water can be, but if you're going to use oil, oil is basically a very good thermal fluid because it can really absorb the temperature immediately without losing heat, and it can easily release the heat also. तो हम क्या करते हैं, काफी थर्मल डिवाइसेस में क्या करते हैं, सोलर कलेक्टर जो हम ले रहे हैं, जो मैं दिखाने वालों जो आपको समझा रहा हूं मैं, वो सोलर कलेक्टर्स में वी वांट टू यूज ऑयल. तो सोलर रेडिएशंस में जो बिल्कुल हीट आती है, ठीक है, मैं एग्जांपल दे रहा हूं फिर आगे मूव कर दूंगा, समझा रहा हूं आपको. आप करो घर में आपके ना तेल पड़ा होगा वो कोकोनट वाला और पानी पड़ा होगा, दोनों को आप धूप में रख दो 1 घंटे के लिए, 15 मिनट के लिए धूप में रख दो और थर्मामीटर से टेम्परेचर देख लो, 15 मिनट में टेम्परेचर किसका रेज ज्यादा होगा. ठीक है, तो सेम फंडा इज बीइंग अडॉप्टेड हियर आल्सो. हाउ व्हाट आई एम सेइंग, द ऑयल इज बीइंग गिवन टू द सोलर in the design of solar thermal collectors. So what is that exactly? The solar thermal collectors are going to collect the heat from the sun radiations, and immediately it's being passed to the thermal fluid, which is oil in this category, and oil is immediately going to absorb all the heat and raises its temperatures to 50, 60, 80, 100, 200, depending upon which oil you have used, without getting it evaporated. Now immediately once you take the oil out, you have a heat exchanger. In a heat exchanger, you pass this oil, and the oil transfer its all the heat to heat the water, and water get heated up and converted to steam, and steam can be directly taken to the turbine and accordingly route you know it. Okay, so this is overall picture what I'm discussing over here, but the main thing is how to have the receiver system, how to receive the excess amount of heat so the high temperature can be achieved. So for that you have two type of receiver systems. अब receiver system क्या होते हैं बेटा, मैं आपको समझा दूं पहले, फिर आगे मूव कर जाऊंगा. बस कुछ नहीं है बेटा, रिसीवर सिस्टम को दिमाग में लेके आना. तो आपके घर में जो डिश एंटीना लगाओ ना बाहर, एयरटेल का या टाटा स्काई कोई भी लगे हुए हैं, तो उसमें देखा होगा आप, पैराबोलिक डिश है और सेंटर में रिसीवर सिस्टम है ना. तो बेसिकली क्या होता है, पैराबोलिक पे सब स्ट्राइक्स करती हैं आपकी रेडिएशंस, एंड दे आर गोइंग टू कंसंट्रेट ऑन द सेंटर रिसीवर सिस्टम, जहां पे आपका रिसीवर लगा हुआ है और उस रिसीवर से सिग्नल जा रहा है आपका. तो सेम फंडा है हियर आल्सो बेटा, सेम फंडा आपका यहाँ पे भी है, देखो जरा. ठीक है, सो फर्स्ट वन इज अ डिस्पर्स और डिस्ट्रीब्यूटेड रिसीवर सिस्टम्स. सो यू हैव अ पैराबोलिक ट्रफ कलेक्टर्स. व्हाट आर दोस, अभी आपको बताया है, आगे दिखाऊंगा भी बेटा, नो डाउट. डिटेल डिस्कशन मैं करूंगा अभी टाइम आपके साथ बच्चे, ठीक है, अभी करूंगा. बट आप assume कर लो, you presume it to be your dish, the cable dish. ठीक है, द पैराबोलिक टाइप, दिस वन, ओके। सो इन द पैराबोलिक सिस्टम कलेक्टर विद द लाइन फोकस, और इट कैन बी लाइन फोकस और इट कैन बी इंडिविजुअल फोकस, ठीक है जी। अब आपका जो केबल है ना वो इंडिविजुअल फोकस है, पॉइंट फोकस, सॉरी, और मैं बोल सकता हूँ उसको पॉइंट फोकस, ठीक है। और इट कैन बी लाइन फोकस, लाइन फोकस क्या होता है मैं आगे दिखाऊंगा आपको बेटा। सो इंस्टेड ऑफ अ पॉइंट यू हैव अ लाइन, स्ट्रेट लाइन। तो स्ट्रेट लाइन में कोई ना कोई आपको ट्यूब जारी होती है, ट्यूब में आपका ऑयल है जो ऑयल हीट अप होता है ठीक है। सो ईच कलेक्टर इंडिविजुअली, तो अकेला अकेला कलेक्टर देख, 1 कलेक्टर, 2 कलेक्टर, 3 कलेक्टर, इसके सेंटर में पॉइंट में रिसीवर लगा हुआ है, ठीक है, एक्सिस ऑफ पैराबोला आई कैन सी, ओके। So each collector individually heats up on receiver and receivers are connected with the piping system or the flow of fluid, जो मैंने अभी बताया आपको, ओके। एंड सेकंड कैटेगरी इज सेंट्रल रिसीवर सिस्टम्स। अब ये क्या है मैं आपको बताऊंगा बेटा, हम दिखाने वाला हूँ। सेवरल सेंट्रल रिसीवर सिस्टम में क्या होता है आपके यहाँ सेंटर में एक रिसीवर सिस्टम है और यहाँ पे सब जगह पैराबोला लगे हुए हैं साइडों में। तो सारा पैराबोला क्या करेंगे, सारे पैराबोला इनकी एंगल डिफरेंट कर रखी है। सो व्हेन द एंगल इज डिफरेंट, तो क्यों, बिकॉज ये सारे पैराबोला क्या करेंगे, रेडिएशंस को ट्रैप करके सेंट्रल रिसीवर सिस्टम फेंकेंगे यहाँ पे। तो ये यहाँ पे 1 2 3 पैराबोला लगे हुए हैं, तो ये सब ने रेडिएशन ट्रैप करनी है, रिफ्लेक्ट करनी है, यहाँ पे सेंटर में फेंकनी है। सेंटर में आपकी मेन रिसीवर लगा हुआ है, द सेंट्रल रिसीवर सिस्टम, ये वाला, ठीक है। तो ये मैं आपको दिखाने वाला हूँ बेटा, ओके। सो दिस इज बेसिकली टॉकिंग अबाउट फ्लैट प्लेट कलेक्टर्स, जो भी मैंने बताया था आपको, पढ़ो उसके एक बार जरा। तो मेरे ख्याल से सोलर वाटर हीटर का फंडा सेम ही है बेटा, जो आपको यहाँ पे दिख रहा है ना। So these are flat plate collector systems. Okay. So what is that exactly? You see this. You have this glass cover, and this is your absorbers over here. 1, 2, 3, all kind of things. And this is insulation. Why you provide insulation? Because you don't want heat to get loose outside. जो भी heat है ये सब खत्म बाहर. Okay. अब ये क्या है बेटा, देखो, डायरेक्ट रेडिएशन और डिफ्यूज रेडिएशन। डायरेक्ट क्या होती है, जो डायरेक्ट आई है, डिफ्यूज क्या होती है, डिफ्यूज जो डिफ्यूज होगी यहाँ से आई है इसके बीच में से, ओके। तो जब अंदर जाएंगी, सो व्हेन दे गेट इनसाइड दिस हीट ग्लास कवर, ओके, सो व्हेन दे गेट इनसाइड दे आर बीइंग ट्रैप्ड इनसाइड, when they're trapped inside they continuously being absorbed by the absorber fluid over here in the absorber tubes, okay। So once absorber में क्या हो सकता है, it can be oil, it can be simply water also। तो ये बेसिकली फ्लैट प्लेट कलेक्टर होगा बेटा, ठीक है। these are flat plate collectors, so they are not reflecting anything, they are not concentrating anything, it's just receiving the radiations directly from the sun, nothing else, okay। so convection लिखा है, रेडिएशन लिखा है, ये कुछ नहीं बेटा। कन्वेक्शन इज अ फिनोमेना ऑफ हीट ट्रांसफर, मैकेनिकल इंजीनियर सब पढ़ते हैं फंडे बेटा, आप पढ़ोगे इसके बारे में, आपको थर्मल का पूरा सब्जेक्ट आएगा इसके बीच में। कन्वेक्शन इज अ मोड ऑफ हीट ट्रांसफर बाय मूविंग फ्लूइड्स, ओके। सो ये फंडे हैं, इसमें कुछ नहीं है। तो मूविंग फ्लूइड्स के बीच कन्वेक्शन, थ्रू कन्वेक्शन होती है, तो हीट अप हो जाएगा, तो हीट जो है वो हीट यूज हो जाएगी आगे जो भी पर्पस के लिए यूज करना है आपको, ठीक है। दिस इज पर्टिकुलर फ्लैट प्लेट एंड दिस इज फोकसिंग बेटा, जो मैंने अभी बताया था आपको। फोकसिंग में देखो ये बताया था ना, अब ये कोई बताएगा पॉइंट फोकस है लाइन फोकस है, चैट बॉक्स में बताएगा। मैंने फोकसिंग में दो बताए थे, पॉइंट फोकस और लाइन फोकस, ये कौन सा है, चैट बॉक्स में बताया कोई। बता दे कोई चैट बॉक्स में, नहीं बताना तो मैं आपको अनम्यूट कर रहा हूँ। हाँ, इट्स अ लाइन फोकस, प्रियांक गुड, इट्स लाइन फोकस फोकस। पवन राय यस गुड बेटा, ठीक है, इट्स अ लाइन फोकस, ठीक है बेटा। So simply you have a parabola design, you design a parabola and mechanical engineers है very well efficient designer में designing है parabola. Parabola design किया बेटा, design करके axis define की कहाँ पे आ रही है उसके लिए, you install it according to your sunlight radiations, and all the solar radiations are falling it are being concentrated on the line, and in the line you have fluids coming in, getting heated up, fluids going out. See the red common notation in the industry. When you see the red notation, it's hot. So blue, it's blue नहीं है, it's like this green, but it's a blue. Blue is always for cold fluid. Okay. See, focusing systems collect solar energy at a sufficiently high temperature, and that used to use the energy in the heat engines to generate electric power efficiently. Okay. So I explained to you what is being written over here. I have explained you each and every point. Still, you have any doubt, you can ask me. Okay. I think so. I can stop here because I am moving far ahead from what other faculties are teaching, taking care. So if you have any doubt, you can ask me. Yes, beta, any discussion you want to have, because 9:30 is always there. 10 minutes, sorry, 5 or 6 minutes are left. 32 is there. So I'm stopping here before I'm not going fast, because I could have covered more syllabus right now, but I'm just leaving it here.